So 9-2, proving that quadrilateral is a parallelogram. So everyone's attention up here. Think back to yesterday. All right? You shouldn't even really need the theorems for this, but if you want to grab a book and look on page 454, you can. But there are 4 ways that the book describes these 4 theorems. 4 ways to prove that a quadrilateral is a parallelogram. Okay? So think back to yesterday and what we talked about parallelograms. What were the properties of the parallelograms? Okay? If you can think of those properties from yesterday, then you will have the 4 ways. So what were the unique properties of a parallelogram? Go ahead and talk to your neighbor about it. All right, so my guess is you came up with a few. Yeah, if you haven't grabbed a book yet, go ahead and grab it and look up those theorems now. Page 454. You can read the amazing math humor there. That's pretty good, dude. Come on. Good stuff. Real quick. So, Theorem 9.5. If the diagonals bisect each other, then it's a parallelogram. So, as you're maybe sketching some of these out, you could draw in your diagonals and show that, hey, that is that is that. If diagonals bisect each other, then it's a parallelogram. So we'll kind of zoom in there. That's one way. Bisecting diagonals. 9.6, if one pair of angles are both parallel, one pair of sides are both parallel and congruent. Now that's not really one we talked about yesterday, but if you have a set of sides that are parallel and congruent, then that is a parallelogram. One set of sides, both parallel and congruent. Hi.
Aren't these 4 just the converses of the original 4?
Some of them are, yeah. Yeah, I don't think we had this one yesterday. Yeah, but the others are. Yeah, converses. Good job using the shoe terms there, or the the logical terms. But you guys wear cons anymore? Converse?
Converse?
Yeah.
I wear Converse.
Oh, very good.
I wear
All right. 9.7, if both pairs of sides are congruent. Okay, this was a converse, yes. Yesterday, there we go, there we go, there we go, there we go. Neato burrito. Okay. If both pairs of what? Opposite angles. Opposite angles are congruents. There we go. Mine are pretty good. Oh, yeah, I thought you were talking about. Okay. All right, so those are 4. Can we think of a 5th? But it's kind of an easy one. What is a parallelogram?
2 sets of parallel.
Yeah, 2 sets of parallel sides.
Yeah.
There we go. If you have 1, 2 sets of parallel sides, it's a parallelogram. You're like, well, duh. I know. Seriously. There you go. You could have done them all in pictures. Could have annotated the pictures a bit. And there we've got it. Any questions? All right, so yes, as Emily pointed out, it's a lot of like the converse of yesterday. Now that is, you guys can chuckle real quick before we move on. Dude, that's funny.
Chuckle?
Look how far it is. So far. Whatever. That's all right. All right, everyone take a look at your assignment. Example number 1.
Oh my god.
You guys got to start reading some good humor, not the ice cream either. Okay?
I like that one up there. It's like the square root of -1. I didn't know what that was.
That's all right. All right, number 1. Complete the following paragraph proof of Theorem 9.5. If diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Now remember, you're trying to prove Theorem 9.5, so you can't actually use 9.5 to prove that. Okay? So we're given FH and G bisect each other. You may want to mark those in, and then go ahead and work with your partner there to see, fill in the different statements and reasons. Go for it. Here we go. FJ. Well, let's label what we have. We have FH and GI. Now that's kind of hard to label sometimes because you have these the whole lines here. But we can remember that this is congruent to that guy, right? Okay. We have that. they bisect each other. We don't have that. We have this is congruent to that, and that's congruent to that. Now, just because they say bisect doesn't actually mean we can mark that. We actually have to state that in here, which is what they're saying here. How come?
Definition of a bisector.
Whoa.
Good. Definition of bisecting lines. Right, well done. All right. Since vertical angles are congruent, angle FJI is congruent to angle HJG. All right, well done. So we should mark that in FJI. Oops, FJI. So right there and HJG. Good. Boom. All right. And FJG is congruent to
HJI. I can't say things.
HJI. All right, angle HJI. Therefore, the triangle FJI and HJG and triangle FJG and HJI, so this triangle right here, and this triangle, and then the other two that aren't shaded are congruent by side angle side, SAS. Sauce. Okay? Other side angle side postulate. Angle FIJ is congruent to HJG or GJ, and FGJ is congruent to HIJ. Holy moly. I know, seriously. So FIJ, so this one right there is congruent to this one right there, and we're gonna have tons of lines here. This one FGJ, so this one, I'm gonna just put a marking like that this time, and this one, okay, by CPCTC. Now we can't use alternate interior because we haven't stated anything parallel yet. Okay? Yeah, CPCTC. Our picture is getting quite messy, I think. Okay? All right. Since, let me zoom in just a bit there. Since angle FIJ and HGJ are both alternate interior angles and congruent, that means FI is parallel. There's our parallel lines to GH. Yeah, dog. And FG is parallel to HI. Therefore, it's a parallelogram by definition of a parallelogram.
I wrote that.
Or you can say by definition. Anytime you say all opposite sides are parallel, once we've said that, we can use definition. Okay, if it was one of the other four, we'd have to actually state that one. But this one we can say by definition. All right. Questions? How many got it? How many missed one little piece? Okay. How many are awake? Okay, so Blake didn't raise his hand. Blake, come on, dude. All right, here we go. Example 2. There we go. Work with your groupie there. Go through example 2. Ready, go. All right.
Sick for 2 days.
Number 2. Who says yay?
Nay.
Who says nay? Why is it nay, not yay? Grace. Good. They don't correspond. They're not opposite. They have to be opposite. So this one would have to be congruent to that one. So this is no. Okay? Okay? And I'm not going to write out the reason that we just said, but opposites, you have to, yes. Opposite sides have to be congruent. Fine. All right. There. Okay, number 3. Who says yay?
Yay.
Who says nay?
Opposite angles.
Oh, we don't have anyone. Who says yay? Who says nay? Okay, the answer is yes. Now why?
Because the opposite angles are congruent. Alternate interior.
Alternate interior angles.
Why? I always keep thinking of like the alternate.
Alternate interior angles make parallel lines. And you can go this way now and have this one and that one. Okay? Alternate interior make parallel. Uh-huh. Alternate interior angles prove opposite sides parallel. All right, number 4. Who says yes? Yay. All right, we have one pair of good. Okay, who says yay? Number 5, yay? Yay, how come?
Because
What's it called? Bisecting what? Bisecting lines. What do we call those lines? Bisecting diagonals. Good. Bisecting, meaning cutting in half, diagonals, meaning they're not sides. Okay?
diagonals. That's spelled so weird. Diagonals.
Pretty weird. I'll agree. Hey, I had this water bottle yesterday. I've got this water, and the lid was amazingly like smooth when you twisted it off. I was like, unbelievable. You like spin it, and, like you just go, and it spin back on. It was awesome. Yeah, I recycled it this morning, but it was really cool. I was just thinking about it. You know, Kira had a random thought, so I thought I'd have it. All right.
You should keep that water bottle.
I should have kept it, but you know, it needed to be reused by someone else. All right. Example 2. Maybe you'll get that water bottle reused. You never know.
I would be so proud.
All right. Check it out. Number 10. RDC. So this guy is congruent to NAC. So that guy. All right. So we have those two, and we have arc, ARC, and DNC. Okay. Does it give us enough information to prove that a parallelogram?
Yes.
How come? Yeah? Yes. Alternate interior angles. Good. Alternate interior angles. Remember, since you have your transversal cutting this way on it, okay, you have your sides there. Did I hit the wrong ones? I did. Unbelievable. Okay. All right. With that transversal, we have that one and that one. That gives us that and that parallel. And then with this transversal, we have that guy and that guy. All right. Good. How about RD congruent to AN? RD to AN. That's good to know. Good to know. Okay. And RN congruent to RA. So this congruent to that. No. That will not work out for us. No. If we had opposite both sides, this congruent to that and that congruent to that would be good. Or that piece congruent to that piece and that piece congruent to that piece, that would be good. We'd have bisecting diagonals or opposite sides congruent. Those would be good, but one pair of opposite sides congruent and then a diagonal congruent to a side doesn't work out for us. Ain't cool. All right. Questions? All right, let's be done with the example side. Let's go on to the mix. Simon is the mix side. Total yes. Yeah. I'm pumped as well. All right.